Okay. Good evening. I think we are here. So this is probably for a lot of you who are GCSE. I know you're probably not going to be watching much of this stream when it's live because you do have your chemistry tomorrow. You've got your chemistry paper 1. I think often students find biology okay, physics okay generally, and then chemistry is a little bit harder. Let me know what you think. It would of course be great as well. I think I've just worked out you can actually put polls and things into the chat. So what I've got in the chat is, have you at the moment got either a premium plan or access to a school subscription to my website? So it'd be interesting to kind of find out what people have. I know that a lot of people have been doing maths exams today. I know that there's a maths paper 1, like a non-calculator. Also, Joe says, just came back from an AQA AS maths paper 1. Amazing paper. Awesome stuff. Joe, really, really pleased that's gone well for you. The other thing I would like to say is, for everybody out there, especially those of you who are doing GCSE chemistry, there's an app. It's not sponsored by ChemQuiz. I just think it's a really, really useful app. It's called ChemQuiz. You can find it on the App Store on iPhone and I think other things as well. And basically, on the app itself, if I just zoom in, you can find lots and lots of questions. Now, I am going to be doing physics revision later in this, but I just thought I'd go through this for a couple of minutes just to show you what you should be doing later this evening if you're doing chemistry. Basically, you can launch it, and basically you can then find stuff there to do with chemistry. Now, the reason I'm not doing the chemistry is because I'm just going to stick to what I know, which is the physics, and I know that really well. So I do have videos for all of GCSE physics. I haven't made videos about chemistry yet, although maybe I should. But yeah, you can see there's lots of questions here. So say, for example, we did bonding and structure. Let's look at chemical bonds. So which of the following compounds contains ionic bonds? So I guess if it's ionic, you're going to have like a metal and a non-metal. So definitely sodium chloride. There we go. Not too bad. The next one. Which diagram represents the electron arrangement of sulfur, which is S-2. Okay, so that one over there is going to be a little bit more tricky. I would say if it's an ion, it's going to have a full outer shell. And if it's sulfur, I can't remember the formula, but I'm going to guess D. Oh yeah, D. Excellent, there we go. What other good revision websites do I recommend for A-level physics? Says IFTY with a cuppa. You don't need them. Just go to alevelphysicsonline.com. That's all you need. I reckon there's enough on there, and that will take you to other things like Isaac Physics and so on. Okay, right. Okay, the next one. What charge does a sodium ion have in sodium chloride? So we've got sodium chloride here. I can just about see that that's got a charge of, well, there's 1 electron that's been donated from that to that, and therefore I would say the sodium is going to have a positive charge and it'd be +1. Okay, so yeah, an ammonia molecule has a formula, NH3. How many atoms does one molecule contain? Well, there's going to be 1 nitrogen, 3 hydrogen, so the answer would be 4. Okay, so yeah, so that one there is the kind of thing that you should be doing, and you could get through 100 questions, 200 questions tonight before your chemistry exams tomorrow. However, we're going to go back to doing some physics. Of course, if you do want to kind of leave the live stream, I completely understand. I know you've got exams tomorrow. But I will be here tonight. I'll be here on Sunday night, Monday night, Tuesday night, pretty much every night next week. Okay, so the first question is about this circuit over here. So fairly standard. We've got a light bulb, which is going to be investigated. We've got a voltmeter in parallel, an ammeter in series. We have a variable resistor, we've got a switch, and we've got a power source, in this case a battery. So this is for looking at what we call the IV characteristics of a component. I'm going to do a purple day today. So why do we need to have a variable resistor in that circuit? Because what they want to do is they want to investigate how the potential difference across that bulb is related to the current through it. And that means what we need to do is we're going to change the potential difference. So that's going to be our independent variable. And then we're going to measure the current our dependent variable. And in order to change these two things, what we need to do is we need to change the resistance of that whole circuit. That's going to change the share of potential difference across this component, and it's going to change or alter the total current flowing in this series circuit. So they need to include a variable resistor to change the resistance of the circuit. And that means so the potential difference across the lamp, or you could say filament bulb, can be varied. Okay, so that's all it is. All right. So yeah, Joe Smith says that the power supply is fixed, so it's not a kind of adjustable power supply, and that means the only way to change the current or the potential difference is to change the resistance. And the reason that the resistance changes the potential difference across this is because effectively we have at A level what we call a potential divider circuit, and the share of this total potential difference is going to be split between this component and this component, and it really depends on the ratio of this resistance to that resistance. Okay, we then have a load of data here. So we've got some components, A, B and C, and we've got the values for V and values for I. Okay, so they've got a fixed resistor, a diode and a filament lamp, so all standard stuff. Identify the component represented by each set of data. So looking at the data, I would say that looking at this initially, I would say component C, a lot of the time there's going to be no current. And that means if there's no current until we get to a certain value, this is probably going to be a diode. So what you'd have is you'd have an IV graph that looks a bit like that. Okay, so there's no current, and then at a certain value, we then have current flowing. So I would say component C is a diode. And you'd have a very similar thing if you had a light emitting diode as well. If we look at the numbers here, component B, it goes up by 0.03 every single time. So as we have this even interval or even increase in potential difference, we have an even increase in current. And that means what we'd have is something that looks a bit like this if we plotted it on an IV graph. So here, the current is proportional to the potential difference. So that is going to be a resistor. So that's our fixed resistor. And A, well, we can see it goes 4, goes up by 4, goes up by 2, by 2, by 1. So here, what we have is something that goes up a bit like that. Again, it's really just this part of the graph we're looking at. So this one over here would be a bulb. Okay, and you could say, how do I say your name? Yeah, boy. Yeah, talking about an ohmic resistor perfectly. Yeah, so this is right. This is an ohmic resistor. It has a fixed resistance at that particular temperature. Okay, first question, not so bad. I'm just going to check the poll. I'm going to see how many people have actually answered it. So, 41 votes. That's not too bad so far. I can see that 71% of you have got a premium plan, which is amazing, or you've got a school subscription. If you haven't got one already, then make sure you do go and buy one. You can buy them on my website, either GCSE or A-Level Physics Online, and that basically doubles the number of videos that you can see that covers the entire course. And of course, if you don't want to pay for it, and you don't want to buy an individual premium plan, you need to ask your teacher to get a school subscription, and then you can view everything on that website completely for free. Okay. Rahik says, had an amazing A-Level CIE Physics Paper 2 today. Thanks to me and Z Physics. That's awesome. I do know that Z Physics is often here in the chat, and we've made some videos. Great guy. So yeah, he's got some really good stuff. Do I do A-Level or O-Level Physics? I just tend to do GCSE and A-Level, which is kind of what they teach in England at the moment. Okay, calculate the resistance of component A when the current through it is 0.1 of an amp. So this means we've been given something here. We need to find the table of data. So component A, when the current is 0.1, we've got this value over here. So I can write down that V is equal to 0.60 volts, the current I is equal to 0.10 amps. And in order to work out the resistance, then R is equal to V over I. Okay, and V here is 0.60, I is 0.10, which is the same as 60 over 10, or 6 over 1, which is just 6.0 ohms. So the unit would be ohms, and the resistance would be 6.0, but of course you could also just put it as 6. Okay, yeah, these questions at the moment, some of them might be relatively straightforward, but this is revision. This is not teaching you necessarily from scratch. If you want to find harder questions and you buy the full pack of these practice papers, some of the questions do get tricky. They're kind of looking at pushing people to an 8 or a 9. If you want even more harder questions, I'll just get this book. If you are wanting slightly harder questions, I do have this book here. This is the daily workout. This is the first book. And basically, if you are a GCSE student who is going to be doing A-level physics, then you need to be buying this book to work through over the summer. And that means if you do just maybe 10 minutes of questions a day, that will really help you prepare for when you start A-level physics. And then there's questions that start A-level as well. So these questions here are designed to be done every day. There's going to be new content that's introduced that you might not be familiar with. And also, as you do the book, it's going to basically help set you up for the rest of your A-level course. And there's answers in the back, and there are work solutions and videos on my website. So that book there, The Daily Workout, is useful if you are a GCSE student who's going to be doing A-level. Okay, the next question. Describe how the student could change the circuit to obtain negative values of the potential difference and the current. So we had that simple circuit, and basically what you need to do is, in order to kind of have the current go the other way around that circuit, you basically need to reverse the polarity. So you could basically switch the leads on the battery. Okay, and that's going to basically, basically reverse the polarity. So now you have a potential difference going across the other way. We have a current going the other way. And what you find is, for the fixed ohmic resistor and the filament lamp, you have the same data, but when you've got the diode, it doesn't let any current through. Okay, there we go. Good question. Rexy, do I like chemistry? Yes, I do. I think physics is better because I find it easier personally, but I do enjoy chemistry. I think at some point, there's got to be a point surely when somebody makes like a GCSE chemistry online in the same way that I've done it for physics, or a chemistry A-level thing online. I know that there are people out there making videos. I would say for chemistry, you've got Mackham Guy, who's really good. You've got Primrose Kitten, she's excellent. I think even Free Science Lessons has done some chemistry videos, I believe. So yeah, I reckon there's going to be somebody out there quite soon making even more chemistry videos. I really, really like it as a subject. Okay, right. Some isotopes are unstable and emit nuclear radiation. We know that. Circle one of the following statements that describes which emissions will result in the formation of a new element. Is it alpha, alpha and gamma, alpha and beta, alpha, beta and gamma? Well, in order to answer this, we need to remember that an alpha particle is 2 protons and 2 neutrons. And when that's ejected, then it's going to mean that the total number of things in the nucleus of that atom decreases. And that means we're going to form a new element. Also, if you had maybe, so that's alpha up here. If you had a beta particle, that's a high-speed electron emitted from the nucleus. And when the beta particle is emitted, we have the formation of a proton from a neutron. So that changes the proton number, it changes the element, and basically gamma is the only one that doesn't change it, because gamma is just a bundle of energy. So, so it won't be alpha and gamma. It won't be alpha, beta and gamma, because gamma's not the correct answer. And therefore it would be alpha and beta only, and that's the correct answer. Okay, can I do a complete paper 1 run through the day before GCSE physics paper 1? Angus, good question. The problem is I can't show real AQA papers, but I am doing these kind of paper 1 things. So I'll see what I can do. I'm definitely going to be doing paper 1 style questions, and what I kind of think are the likely kind of questions which are going to come up on paper 1 on, is it Wednesday, your exam? Is that right? You've got English on Monday, you've got physics on Wednesday, and then another English on Thursday, is that correct? Yeah, I basically will be doing the kind of paper 1 style questions and lead up to it. Okay, state the type of radiation emitted by the source and explain your answer. Now, in order to answer this, we have to look at this table of data here. So they've basically set up a counter with a Geiger-Müller tube. So the Geiger-Müller tube is going to actually detect the radiation, and then that's displayed on this big counter over here. We've got our cup source, which is going to be emitting radiation out, and that's going to be, well, some of it is going to be going through the material and detected by the GM tube. Okay, so these summarise the results the teacher obtained. So when there was no material in the way, that was our count rate per minute, so 3,500. When you had a piece of paper that was in the way between the radioactive source and the counter, it did go down very, very slightly. But when you put in 5 millimeters of aluminium, it went down even more. But it didn't stop completely. So what kind of radiation was emitted? So would it be alpha, would it be beta, or would it be gamma? Okay, so for a question like this is kind of like a logical question based on the kind of bits of knowledge that you currently have. Sorry, I'm just going to get this one here. So first of all, I would say that looking at the diagram here and looking at the fact that when you've even got a piece of paper, it doesn't affect the count rate, I would say that no alpha is given off. Because if alpha was given off, then you'd notice that when you put in a piece of paper, this number should go down a bit. Okay, is beta given off? Well, some of it is stopped by 5 millimeters of aluminium, and so there's going to be some beta. I'm just going to put yes next to that. Hopefully you can see that okay. And 5 millimeters of aluminium doesn't stop everything, so that means there must be some gamma getting through as well. Okay, and I would say that the difference between these two numbers is kind of negligible, because when you're looking at basically 3,500, and that one there's kind of within the same kind of number, it's not a noticeable difference, I would say. So I would say that beta and gamma are the ones given off. So the paper has little effect. So no alpha emitted. And then you can say that beta and gamma emitted as some still pass through aluminium. Hope that helps, that answer there. Okay, the next one. The teacher repeats the experiment 5 more times, but never gets the same count rate as they did the first time. Explain why that could be. So, why is it? Well, basically, what we have here, when we're looking at this decay of these atomic nuclei, the ones which are unstable, is we have a random process. That means you can't predict when one particular nucleus is going to decay, and that means over the course of a minute, some minutes you're going to have more being decaying, or over the same number of seconds, sometimes you have more decaying than at other times. So, so you could basically say that decay is a random process. And that means you can't predict exactly when it will decay. So that means, 1 minute you might have 3,502, then you've got 3,482, then you've got 3,496, 3,521. Every minute you do this, you get a slightly different number, but that means by taking the count rate over a much longer time period, we kind of smooth out this kind of change in that data. Okay, The teacher has a different source that they know only emits gamma radiation. It's 15 years old, it's got this activity. If the initial activity was 4,400, calculate the half-life of the source of radiation. So for this one over here, there's not really one easy way to do it at GCSE, but I'm going to say write like a big table. So basically, after 0 half-lives, the activity was 4,400 becquerels. Now, after 1 half-life, it's going to be half of that, which is 2,200. After 2 half-lives, it's going to be 1,100. So you can see we're halving each time. After 3 half-lives, it halves again to 550, which is the number that we had up here. Now, what that means is it's gone through 3 half-lives in a time of 15 years. So that means the half-life, I'm just going to call that T1/2, so that's the half-life in time, it's going to be equal to 15 years divided by 3 half-lives, which is 5 years. So the half-life of this particular source is 5 years. You could use logs for this, but again, this is only a GCSE question. Okay, do we have another question? Okay, predict the activity of this source after 4 more half-lives. So at the moment, it's 550 becquerels. Okay, and we're going to think about 1, 2, 3, 4 more half-lives. So my approach again would be to kind of draw a table. So we know at the moment it's 550. After 1 half-life, it's going to be half of that, which is 275. After another half-life, it's going to be 137.5. Then it's going to be equal to 60, whatever it is, but I'm just going to use my calculator for this. So let me just do that. So 550. Sorry. 68.75, of course, divided by 2 again, is 34.375. So the activity, I would say, in becquerels is going to be probably about 34.4 becquerels. Okay, now for that question, that's one way of doing it. There are more elegant ways of doing it. You could have had, for example, 550 divided by 2 times 2 times 2 times 2, which is the same as 2 to the 4. So you could have had 550 divided by 2 to the 4, and that would also give you the same number of 34.375. Okay, right. Hopefully that is useful, especially if you're watching this afterwards. If you are watching this live, though, do you want to do some chemistry? We could do probably 5 minutes of GCSE chemistry before we start with the A-level physics part of the stream. So again, for this, I'm just going to use my phone. I'm using this app called Chem Quiz. So I'm just going to put it down there. Okay, right. So basically just say A, B, C or D. Which statements about covalent bonds are correct? Select one or more. So if it's covalent, pairs of electrons are shared between atoms. Are they pairs? They can be represented by dot and cross diagrams. They can be. They're found in small molecules. I think that's correct. Cool. There we go. A, B and C. Perfect, as Joe Smith said. Right, the next one. The diagram shows how atoms are bonded in methanol. What is its formula? So we've got a carbon, an oxygen and 4 hydrogens, but I would say we've got a carbon with 3 hydrogens, so it's going to be CH3, and then we've got CH4O, so I reckon that's going to be the correct one. So CH4O. So I didn't read the question. Okay, the next one then. Which of the following does metallic bonding occur in? So metallic bonding. So what do you reckon? I think fullerenes are like these kind of big round structures, aren't they? Polymers, I guess, tend to be like long chains. So I would say for something like this, we might have metallic bonding in alloys. Would that be correct? Woo! Awesome new winning streak. Right. What is the molecular formula for the molecule shown? So we've got 2 carbons and we've got 6 hydrogens. So we'd have C2H6, which is this one over here. Which of the following does not contain covalent bonds? So, silicon dioxide, polythene, methane, or steel. I would say steel probably has metallic bonds rather than covalent bonds. So I'm going to say steel for that one. Which diagram represents the electron structure of a sodium ion, Na+? So if it's a sodium ion, it's going to have a full outer shell. And I think because the structure is it 2881 or is it 281? It's 281, so I reckon it's going to be A. So my answer is A. Cool. Found a collector's card. Okay. Which of the following compounds contains covalent bonds? So, which of the following things contains covalent bonds? So, which one do you reckon it is? I reckon it's not magnesium oxide, because that's a metal and a non-metal. It's not calcium chloride, not potassium bromide. I would say ammonia. There we go, like a boss. Right, what is the chemical symbol for a sodium ion? So, sodium is in group 1, if I remember correctly, and that means it would have to lose 1 electron to get a full outer shell. So that would make it positive, and it's going to be Na+. Na+, excellent stuff in the chat from Chris, Alistair, Joe, great answers. What happens to the electrons in covalent bonding? They're shared between them, aren't they? Okay. Methane has a low boiling point. It consists of small molecules, charged ions, long chain molecules, or a giant lattice. So it's not really a giant lattice. It's not really charged ions because we've got some covalent bonding there. It's not a long chain. I would say small molecules. And because they're small molecules, that means they have a low boiling point. Okay, I can do chemistry as well, not just physics. I am able to do chemistry. Right, so I'm getting my tea bag there. Okay, we'll do 2 more minutes of this and then we'll go on to some A-level physics. What type of bonding involves charged particles, I guess electrons, that are held together by strong electroattractive forces of attraction? Is it ionic bonding? So strong forces means you have strong bonds. The diagram shows how atoms are bonded in methane. What is the formula? So methane is CH4. So there's 1 carbon and 4 hydrogens, so it's going to be CH4. What is the charge on a chloride ion? Okay, so on a chloride ion, I would say that because you've got Na+, you're going to have Cl-, and it'd be -1. Score is 17 out of 17 at the moment. Which of the following is a molecular compound? Okay, so which of the following is a molecular compound? Is it A, B, C, or D? Or if you want to write the stuff in the chat, that'd be really good. So which of these is a molecular compound? Carbon dioxide, people are saying. You have molecules of carbon dioxide. Sodium chloride, does that exist more as like in a lattice? Molecular, so what are people saying? I reckon sodium chloride tends to exist in a lattice. Calcium oxide. I'm going to go for carbon dioxide. Yes, there we go. Which of the following pairs of elements can form a covalent bond? So I would say hydrogen and chlorine. The type of bonding in methanol is, so we've got a dot cross diagram here. We've got like a metal and a we've got a non-metal and a non-metal, so they're sharing electrons, so it's a covalent bond. What type of bonding involves delocalized electrons? That would be, if you've got delocalized electrons, you're going to have this kind of metallic structure, so we'd have metallic things. Okay, I'm going to leave it there because I got 21 out of 21 and I don't want to make any mistakes. However, this is something that if you haven't already got it, you can do. So this is called Chem Quiz. You can do lots of questions. I guess you can check your stats and all that kind of stuff. And basically you can launch it. You can choose the questions that you need to revise ready for your exams. Okay, hopefully Hopefully that's good. Are we all good? Right, let's now do a bit of A-level physics. So let me just go out a bit. So tonight we're going to do something again about this is one of the questions from one of my daily workout books. So we're just going to do a kind of a fairly short one tonight because I know a lot of people are preparing for other exams. And also, let me just show you what the plan is for next week. Okay, the plan for next week is we're going to be doing lots and lots of multiple choice questions, so it's easier for you lot to play along at home, and also it means we can cover many different topics. Now, the reason I'm going to use some OCR papers is because I can't show Edexcel or AQA papers on YouTube because I'll get banned due to copyright. So I'm going to be using some OCR papers. These are modelling physics papers, so obviously ideal if you are an OCR candidate. But actually, a lot of the physics is going to be the same for people doing AQA stuff as well. So if you are doing AQA paper 1 on Friday, then all of this is going to be suitable for you. And also, if you are doing AS physics paper 1, I think that's on Wednesday as well, then all of this stuff is going to be, or lots of this stuff is going to be suitable for you. So these are the topics I'm going to be doing next week. My plan is I'm going to do 2022 on Sunday night, then 2021 on Monday, 2020 on Tuesday, and so on. So we've got basically 5 sets of papers. I know a lot of you might know the questions already, but I think it's still useful, especially if you're AQA students. These are questions you probably might not have seen, but they're going to help you revise over the coming days. So that's the plan for next week. Today, though, we're going to be doing something about specific heat capacity, which is again a topic that I think a lot of people struggle with. And we're looking here at something called the method of mixtures. Okay. Right then. Okay, hopefully that helps. Right, so a good question from Chris saying, what should you do if you finished all the AQA physics papers? Where else can I find very difficult questions similar to the ones that came up on 2023 AQA physics paper 1? So what we're going to be doing is, I would say that a good source of questions, I think you don't want to go and get super hard ones because that's just going to not make you feel good. I reckon look at the Edexcel questions. There's loads there. And basically, if you know the topics that are coming up in, say, for example, you know the topics coming up for AQA, it's worth just having a quick check in the Edexcel or OCR specification, see which questions or where those similar questions come up on their papers. So say, for example, you want to do some stuff about ideal gases and thermal physics, have a look at the OCR spec or the Edexcel spec, see which question papers they have those questions coming up in, and then go and just have a look at loads of those questions. I think that's probably one of the best ones. Yeah, okay. So here we've got an investigation into the specific heat capacity of milk. We've got a certain volume of black coffee at 78 degrees poured into an insulated cup. So that's basically what we have over here. The first thing, though, is we're going to suggest a suitable value for the density and a specific heat capacity of black coffee. So the first one is you just need to kind of use your knowledge about the things you've done beforehand. So if we've got black coffee, the density is going to be about 1,000 kilograms per cubic meter. Okay, that kind of makes sense. That's very similar to water. And because it's going to be pretty much mostly water anyway, the specific heat capacity of coffee is going to be round about 4,200. Okay, so I would say that probably similar to the specific heat capacity of water. And that's going to be joules per kilogram per Kelvin, or you could say joules per kilogram per degree Celsius. Okay, I'm just going to end this poll. It's good to see that loads of people have been, here we go, that's, I've got a poll that says 22% of people do subscribe to the premium plan or to a school subscription, which is amazing. But for those other 77%, it says, it's only given me a stat of 99% in total on YouTube. A lot of people haven't subscribed yet, but there's still time if you want to access extra videos. Okay, so that's the first kind of numbers we need. We then have 40 grams of milk from the kitchen fridges added to the coffee. Suggest a suitable value for the starting temperature of the milk. So, especially for those of you who are working in restaurants and pubs, what is the temperature of milk in a fridge? What would you guess is a suitable value? And while people are answering that, I would say it is worth doing legacy papers. Yeah, if you've got legacy ones, so older AQA papers going back from sort of before 2016, then it's definitely worth doing them. So people are saying, so Dono says 5, Matthew says 4, Light, Arjun says 4, 4, 5, Ollie about 2 degrees, 12 degrees. Okay, Joe, I don't want to be eating stuff from your fridge, thank you. Yeah, normally a fridge is about 5 degrees. Okay, that's approximately the value you might have. But you can see what we're doing here is we're just trying to look at what we currently know about maybe the density and the specific heat capacity of water, how that's related to maybe coffee, which is probably going to be similar, and also the kind of temperature you get from a fridge. And as Chris has said, 279 Kelvin, yeah, fair enough. Okay, so the final temperature of the milky coffee is 69 degrees. And then we want to calculate the thermal energy lost by the black coffee as it cools to this temperature. So for this, we just need to use the equation that says Q equals mc delta theta. And that's going to be the thermal change of that black coffee. Now, we know the volume of it is equal to 268 millilitres. Okay, now 1 milliliter is equal to 1 centimetre cubed, which is equal to 1 times 10 to the minus 6 cubic meters. So what we need to do is we need to convert from 268 milliliters into cubic meters. So that's going to be equal to 268 times 1 times 10 to the minus 6. Okay. The specific heat capacity is going to be 4,200. And the change in temperature is going to be the starting temperature, which in this case was 78. And we're going to take away the final temperature, which is 69. And then we just need to work this out. Chris says, why don't I combine forces with Z Physics, Science Shorts and Creative Physics School? Well, I have done some stuff with Z Physics, and I definitely want to do some more stuff with him. Science Shorts, if you're watching, you know, I'd love to do some collaborations. I'd love to work with lots of people and like kind of share this love of physics, because I think we're like the triangle, aren't we, of A-level physics? Me, Z Physics, and Science Shorts. Yeah. But yeah. Okay. Heads, good comment. Appreciate that. I do try and explain everything from scratch. So if we put the numbers in, we've got 268 times 10 to the minus 6 times 4,200 times 78 minus 69 is equal to 9. And that is equal to about is that right? Have I done something wrong there? Or am I good? Have I made a mistake there? Okay. I've made a mistake. I know why, because 1 centimetre cubed. I think that's right, isn't it? Okay, I think I've made a mistake. Let me just do that again. So we've got we need to do the maths, don't we? Yeah, so basically, sorry, what I did here, this is the volume over here. That's the volume, and we know that the mass is equal to the density times the volume. So what I need to do is multiply the density of the coffee, which is 1,000. I need to multiply that by the volume, which is 268 times 10 to the minus 6. Okay, it's also really good to see that there are actually people here in the chat. I've seen that people have got a degree and a full-time job. Why are you here? Tammy, I'm here as well. You know, I've got a mechanical engineering degree and a full-time job. Well, no, this is my full-time job, isn't it? Yeah, right. So this is going to be equal then to 10,130, which is about 1.0 times 10 to the 4 joules. Okay, so I've given my answer to two significant figures, which I reckon is the kind of numbers that we've got over here. Yeah, right. That's the first bit there. So that's the amount of energy lost by the black coffee as it cools down. Okay, and what we're going to assume is that no energy is lost to the surroundings. So that means the energy lost by the black coffee is the energy gained by the milk. So the energy gained or transferred to the milk is going to be equal to the same number, so 1.0 times 10 to the 4 joules. And here we've got a state, which means we don't need to do any calculations, and you just need to find the right number from previously within that. Calculate a value for the specific heat capacity of milk. Well, we can do this, again, using the equation that says Q equals mc delta theta. So we can say, and I'm going to use green to be the energy gained by the milk, Q equals mc delta theta. Now, the specific heat capacity, C, is going to be equal to Q over m delta theta. Now that's going to be equal to the energy gained by the milk, which was 1.0 times 10 to the 4. We know the mass of the milk was 40 grams up here, so that's 0.040 kilograms times the change in temperature, which is going to be the final temperature of 69, take away the initial temperature, which we guessed was about 5. Okay, and again, if we put that into our calculator, right, Ollie, this is a good question, sorry. Sometimes in the questions, the mark scheme only accepts answers which have a different number of significant figures to those used in the question. How do I know when to use more? I reckon, yeah, Joel, I reckon you should give your final answer to the least number of significant figures in the question. I suppose really my answer over here, I'm going to keep my unrounded down answer, which was 10130 times 10 to the 4. And basically, if we do that, we've got 1.013 times 10 to the minus, so 10 to the 4, divided by 0.04 by 64, which is about 3,957, so about 4,000 joules per kilogram per Kelvin. Okay, so it's slightly lower than water, which is kind of what you expect actually. There we go. Okay, if 65 grams of milk was added rather than 40 grams, calculate the final temperature of this milky coffee. So we've done the first bit, which is we know the change in temperature. We now want to find out what would happen if we had 65 grams of milk being added instead. So again, we can go through exactly the same process. We can look at the energy lost by the black coffee and how that is equal to the energy gained by the milk. The energy lost by the coffee is going to be equal to mc, and then we're going to have, I suppose, delta theta, and that's equal to mc delta theta for the milk. If we put the numbers in, we know the mass was equal to 0.268 kilograms. The specific heat capacity is 4,200, and that's multiplied by our change in temperature. Now here, we know the starting temperature was 78, but we don't know the final temperature, so I'm going to call that TF. Okay, that's the final temperature of the milky coffee. That's going to be equal to the mass of milk, which is 0.040, multiplied by the specific heat capacity of milk, which is what we've worked out up here in that last bit of the question. And then we're going to multiply that by the final temperature of that milky coffee, TF, minus 5. Okay, so what we have here is an equation which looks a little bit complicated, but I would say we just need to multiply a few things out. Okay, and actually when you do that, will you get marked if you use the final temp formula? Sorry, there's a lot of questions coming up, and I will answer your questions in a couple of minutes' time. So basically, what you need to do is kind of multiply this out, and basically what you can find here is that 87,797, which is this times this times this, take away 1,126 times TF is equal to 257 times TF, take away 1,286. Okay, and when you do this, you can basically bring all the TF terms together, divide everything by that number, and this then means that the final temperature TF is equal to 64.4, so about 64 degrees, which is kind of what we expect. So basically, when you add 40 grams of milk, the temperature goes down to 69. When you add 65 grams of milk, so you're adding, oh no, sorry, that wasn't 64, was it? It was 0.065. When you add more milk, the temperature goes down even more, down to 64. Okay, write the units in for specific heat capacity in its base units. Okay, so this one over here, it might be a bit difficult for those of you in the chat. Now the base units, well, the units we tend to use normally are joules per kilogram per Kelvin. Okay, so we need to think about what are the base units for joules. Okay, now I might think of a joule is the energy transferred, and energy transferred might be, you can maybe calculate this by looking at half mv squared. So another way to write a joule is you've got the mass, which is in kilograms, times by meters per second squared. So you can also write a joule as a kilogram meter squared second to the minus 2. So if you're not sure, it's quite an easy thing to kind of work out. Okay, now we're going to replace this joules up here by kilogram meter squared second to the minus 2. We're going to multiply that by kilograms to the minus 1 and multiply that by k to the minus 1. Now you can see here we've got kilograms and kilograms to the minus 1, so they cancel. So it's also meters squared s to the minus 2 k to the minus 1. Okay, so that is the base units for specific heat capacity. Okay, hopefully that's all right and making sense. Okay, right, so I was going to go through some of the questions that people have in the chat. If you want to find out any more to kind of help you, don't forget, of course, that I do have a couple of videos over at A-Level Physics Online, and I kind of explain everything from scratch. But let's have a look at some of the questions that people have got. Okay, at a guess, what topics do I think AQA might focus on this year, Chris? I have no idea, and I don't think it's worth trying to guess what might come up based on what's come up previously. I think the people who do well, from my experience, the students who do well, the people who do well in exams, they revise everything. They don't leave anything out hoping that something else is going to come up instead. So they don't kind of miss out this particular area of physics because they don't like it. Instead, they've got a good kind of broad knowledge across everything on the course. I think it's very hard to predict what might come up. I mean, yeah, you're not going to get an identical question to what came up in 2023, but I don't think there's a way you can really easily predict what's going to come up and therefore focus on those topics. Okay, hopefully that helps. Right, so... Okay, somebody thinks that on paper 1 there'll be a big question on the photoelectric effect. Ollie, there could be. I mean, often the photoelectric effect comes up every year. It's kind of one of the staples, and it's kind of, I think a lot of people find the quantum stuff a little bit difficult because it's so different to anything from before A-level. So yeah, there's definitely going to be some kind of quantum stuff within it. No idea what it might be yet. Okay. Nasty wave questions, possibly. So, in its gravitational field strength, is it for the F equation or is it for the G equation? Yeah. Do I think that physics is harder than further maths? I think that there are bits of further maths which are more tricky. but there are also bits of physics which actually can be quite tricky, even though they're not mathematical. So I would say like the quantum physics, it's not that mathematical, but it can be tricky, like the concepts. Also, there's quite a lot of knowledge involved in A-level physics, especially looking at some of the optional topics. You know, if you're doing turning points, there's a lot of information there that you've got to take in. Yeah, so I think that some aspects are harder. I think the maths in further maths is a lot more difficult, but actually if you like maths, it's actually relatively straightforward, and therefore it's relatively, not straightforward, but it's easier to prepare for what might be come up in the exam. What grade did I get in physics A-level, Ollie? Yeah, so when I did A-level, I got a grade A because at the time I did it in 2020, and at the time an A was the highest grade. So yeah, so basically I got an A for A-level physics. What is the equation for gravitational field strength? Okay, so for gravitational field strength, I know why you're confused. Okay, right, heads, awesome stuff, thanks so much. Thanks for helping with your grade. Also, please do some OCR AS papers. I think I've got a couple on my website that I've already done. If you look at my A-level physics online, I think I do have a couple of OCR AS papers that you can see there, but I don't have many. I don't have enough. I appreciate that. Okay, right. So, looking at the equations for gravitational fields. So gravitational fields. What colour is that? That's a blue colour I did. Yeah, I think these ones here are difficult because a lot of them, they're quite similar. Okay, and I think it's often worth writing them down. So G equals GM over R squared. Yeah. Okay. So I would say that these equations do look quite similar. Okay, so there's like a G and there's an R, and like there's this kind of gravitational potential, which is kind of related to R, whereas the gravitational field strength is related to R squared. And I think that these two are quite similar because the gravitational field strength, and I think maybe something, have I messed up the negative sign, Enderman? Yeah, so basically these do have negative signs, but sometimes they don't. This is the thing. Yeah, I reckon sometimes they have a negative sign and sometimes they're not given one. I think it really just depends on sometimes the exam board and sometimes the question. But often what we're really interested in is more about like the magnitude of that force or the magnitude of that gravitational field strength. Tom, awesome, thank you very much. Okay, so there's some really good questions coming up. I will answer these. Ollie, I will answer your question about turning points. F equals minus GMM over R squared. So I reckon if we think about this one, the force, if we think of the force as being a bit like weight, we know that weight is equal to mass times the gravitational field strength. And basically, if we put this back in here, we could say that mg is equal to GMM over R squared. And then you realise there's an m there and an m there to say that G is equal to GM over R squared. So basically, that's a way of kind of converting this one into this one. But I think it's just an area where you just need to do as many questions as possible to see whichever exam board you're doing, which equations they give you, and actually when it's most appropriate to use them. Oh yeah, also having G equals F over M. So G is our force per unit mass. Okay, right, somebody says, is revising the whole of paper 1 in 7 days and ending up with a C possible for physics A level? Yes, because you're not revising it from scratch in 7 days. You're revising it from basically spending years doing A-level GCSE physics, and you spent the last 2 years doing physics lessons at school. So you're not starting from scratch to try and get a grade C in 7 days. You're kind of starting up here, and you just need to do that a little bit more to kind of get to the kind of grades that you're after. Somebody says, Ollie, You do turning points. Would I advise self-learning astrophysics next week to do the exam? Ollie, no, that's an awful idea. I reckon spend that time just doing turning points. By the way, if you want to find a load of work solutions to turning point answers, I'll put the link in my chat here. Sorry, I'm just going to find it. So what I did was I did a load of work solutions for AQA things. A lot of these can be found on the physics and maths tutor page. But basically there are extra solutions including all of the turning points. So sorry, I'm just losing my window. Basically, if anybody clicks on that link I've just put in the chat just now, then you can download lots and lots of work solutions to turning point AQA physics questions. So yeah. Okay, right. Sepultura 619. Yeah, thank you so much. I've still got loads more help to give over the coming weeks, so it's not over yet. People are saying that AQA people are weirdos. Yeah, I suppose AQA is different because of the optional topic. I did like teaching AQA. I probably preferred OCR because it meant everybody got to do a little bit of medical, a little bit of astro, and people didn't miss out these kind of big bits of physics. But then I do like that. I do like that with AQA you can go really deep into some of the topics. Do I have a workbook for Year 12s finishing up their first year of physics? Joe Smith, excellent question. I have a couple of workbooks here. The first one, if you're in Year 12, you should be doing this book now. This book here has revision for your Year 12 and AS exams. So book 3, you can start it at any time. What's the date today? The 16th of May. So if you had the book, then today you'd be doing questions about EMF, internal resistance, uniform beam, and basically there are questions here that go through all the rest of May, and there's a question to do, or a couple of questions for every day in May and June, and there's also like revision tips and so on. And when you finish this book, Year 12, you need to buy this. This is going to stop you stressing like the Year 13s in the chat at the moment, because this book has questions for all of July and August and September for your whole summer holidays. It has lots of stuff about logs, which is going to be incredibly useful to you. And then it keeps going through August, into September, into October, I believe. It has loads of stuff here that introduce the Year 12 things about SHM, thermal physics, and so on. So there we go, some good stuff there about the motion of a particle. So the book is just £9.99. You can buy it on Amazon. But I reckon if you did this book, then this would help you have a really good start to Year 13. And that means if you're in Year 13 and you haven't got the book, just imagine how much better at physics you'd be. You wouldn't be stressing now, you'd be like super. I mean, you are good at it, but you'd be even better. Okay, somebody says, you're in Year 12 now, but you're kind of scared about going into Year 13 because there's more stuff that AQA YouTubers don't cover. That's true, but I cover the entire course. So if you want to find videos about all of turning points, about all the stuff to do with magnetic fields, electric fields, about atomic physics, nuclear physics, I've got the whole course over at A-Level Physics Online. So don't worry, heads, you can find more stuff there. Yeah. Okay. Hello, Izzy. Nice to see you. People need advanced information. You don't need advanced info. I think the problem with advanced info was that some people only revised what was on the list, even though the questions about any part of the course could have been asked. So you don't need the advanced information. You just need to learn everything and then you'll be fine. Are my exam papers unique from the other ones online? Yeah, so I've got some unique past paper questions you can buy. These are either packs or like practical skills packs for Edexcel and OCR, or they're split into papers 3A, and I've got an alpha, beta and gamma. They're completely unique, and you can find them in my shop. Okay, right. Right, so somebody's Enderman, I think you're doing the right thing. So you're aiming for an A star. You know the content very well. How to work on problem solving skills. I've done all the past papers for OCR. I would say that the best place to go to is either Isaac Physics and look for the game boards that are kind of difficult. So I think Isaac Physics has lots of questions. I think probably the ones from Olympiads are a bit too hard, but I reckon if you did 3 weeks of Isaac Physics questions on the topics that you need to investigate and you need to work on. That would really, really help you. Right. Okay. If you've got the Isaac Physics book, that's good. But I would say that what you need to do is you just need to go to Isaac Physics on the website, and you need to basically select physics, select the topic, and there's like thousands of questions which aren't in the book. So if you go to the website, there are additional questions that aren't in the book, and they're really, really good for you. Okay, hopefully that helps. How to prepare for the IFO. G Dominators official. Yeah, basically just do. I don't know what to do because the questions are so weird, but I reckon to prepare for things like the International Physics Olympiad. Obviously, I suspect if you're on the actual team, you will have been over at Oxford over at Easter. But I would say what you just need to do is as many British Physics Olympiad questions as possible. That's going to help you loads. Isaac Physics isn't my book, although, yeah, so basically the Daily Workout is my book. This one over here, so just look for that. That's my book, and that's my name over there. Isaac Physics is a bigger project. It's really well run. It's a really, really good thing that you should be involved with. So also, I made videos for Isaac Physics for the GCSE book. So if you look at hint 2 for any GCSE question, that's my hands. Okay, thank you everybody tonight. I really appreciate all of you being in the stream. I should be back again tomorrow. No, not tomorrow because it's Friday. I'm not going to do this. So I will be back on Sunday where we're going to be doing lots and lots of paper 1 practice and revision ready for GCSE and also for AS Physics and the full A-level physics. So it's all about physics, paper 1 next week. Goodbye Izzy, goodbye Ollie. Yeah, G, yeah, brilliant. Right, good night everybody. It's good to see so many people in the chat, and I will speak to you all soon. Good night.